and the ends are maintained at temperature T1 and T2. So what will be the thermal resistance of this particular rod? Then, so what is the formula? The heat current, or what we have that one. So how do it will flow? That one, it will flow along the axis. So what is the direction of heat current? The direction of heat current will be in this direction. Then what you should do, perpendicular to direction of flow of heat current, you should assume an elemental surface. So what is the elemental surface? It will be, shall we put a disk? The elemental surface will be a disk. So what is the thickness of this? Let it be dx. So first we'll calculate what is the resistance of the small elemental disk. Let it be dr. How that elemental structure we should assume? The elemental structure should be directed. The heat current or the rate of flow of heat or the thermal power should be such that it should be directed normal to the elemental structure. There's a method of assuming elemental structure. Okay, got that one? Okay, what is the resistance of that elemental structure? Resistance of, so that is equal to dr is equal to, what is the resistance usually? L by Ka, the thickness of this is dx, K, area of cross section. Area of cross section is A, which is equal to pi A square. Later on we'll write it. This is the resistance of that elemental structure. Now let me put it like this. This is x equal to 0. This is x equal to L. I want the total resistance, thermal resistance. Then I'll go for integration. Tell me like the dx from where to where it will vary, from 0 to L. So therefore R is equal to L by Ka. So this is a cylindrical rod. Thermal resistance of cylindrical rod is what we have found out. How much it is? It depends upon the length of the cylindrical rod, K, and area of cross section. Further, what is A? Pi A square. The first case I started. So what is a methodology here? You should assume an elemental structure. So how to assume now you can ask questions. So why don't you assume a, instead of this elemental disk here, what is this elemental structure? Or you can call it as a disk. If I add up such a disk, what do I get? If you look at the loaf of a bread, there what happened, the slices, when you add all those slices, what you get? You get a loaf of bread, loaf of a bread. Similarly here, such a disk, if I join, so what do I get? I get this cylinder. So what is this cylinder? Solid cylinder we should assume to be made up of. The solid cylinder, we should assume it to be made up of elemental thin circular disk. Such a circular disk, when you add up, you'll get a solid cylinder. Are you able to say this is very important? If you can assume what elemental structure, if you are going to assume, if this is correct, then it's all about the assuming limits. From way to way, this material is available from x equal to 0 to L. The limits will be like that. Then we'll proceed here. Okay, agree this. The same thing, what happened, you are going to get, this will get repeated for you in current electricity chapter in second year. So what all you study now, it's going to indirectly help in that particular chapter. Okay, there's a cylindrical rod. Okay, next we'll take it. If it is a tapered rod,